Well, welcome everyone. Glad you could join us. I'm Ken Clairbout, K4ZW, on behalf of the Potomac Valley Radio Club. Glad you were able to be here this evening, morning, whatever local time you may have. We've got a great presentation this evening, and I know you guys didn't come here to listen to me talk, so with that, I'm going to just go ahead and pass it right over to Dean, N6 Delta Echo from the Northern Cal Contest Club. Dean, go ahead.
Thank you, Ken. Dean N6DE here. Welcome, everybody. Pleasure to have you join us tonight for the webinar. It's a joint webinar between PVRC and N6BV featuring Dean Straw, November 6 Bravo Victor, going to talk to us tonight about the tactical use of propagation predictions for HF contesting. Well, I believe this is Dean's third webinar here, so I think most of you should know him by now, but he was a senior assistant technical editor of the ARRL for 16 years, past editor of the ARRL Antenna Book, ARRL Compendium, and a lot of other publications. Yale engineering grad. We often seek his advice on the topics of antennas, transmission lines, and HF propagation. And he's also an active contester, often from the N6RO station. So before I turn it over to Dean Straw for tonight's presentation, just wanted to remind you about the format tonight. What we're going to do is we're going to go through Dean's presentation in full, and then we're going to take the questions and answers at the very end. While we're going through the webinar, if you have a question, feel free to, on the right side of your screen there, you have the option to enter a question. Feel free to just go ahead and enter that instead of trying to remember it to the end. And when you enter your question, you'll see a page number on whatever slide that Dean happens to be on. Go ahead and note that page number down as well. And at the end, we can take your question right away and go right back to that slide. And
Dean, if I could just add one other thing. Also, if you submit a question, I'd appreciate it if you put your call sign at the end of it so we know who the person is and their call sign.
Terrific. With that, I want to hand it over to Dean Straw, N6BV, for tonight's webinar. And Dean, let me change the presenter to you, and we'll have you share your presentation.
Okay, I think I am now on the air here. Hello out there in Radioland. I was talking with Ken Clairbout before we started this webinar, and he had been kind enough to send some data on the number of hits on the hints and kinks for using HFTA, the webinar that I gave back in August 5th, 2009. And Dean Wood, N6DE, had been kind enough to send a partial list of downloads from the N6BV site for the second one that I gave, which was in September 24th, 2009. That was called Hints and Kinks for Using HFTA. And Ken and I had been discussing the wonders of this new medium, where there's just almost 5,000 downloads of the two presentations in the space of less than a year. To me, that just kind of blows my mind to see the international scope of this medium of communication by webinar. So tonight, I'm going to talk about the tactical use of propagation predictions for HF contesting. And when I think about tactical, my mind goes wild, and I think about Revolutionary War and cannons, and diverge into thoughts about contesting as all-out war. But then I bring myself hopefully back a little bit to earth, and I look in the dictionary and find that the word tactical is the adroit in planning or maneuvering to accomplish a purpose. So that's the real use of planning things in a tactical basis. What is the purpose of planning something tactically? Well, the ultimate purpose is to boost our contest scores and hopefully even to win some contests. That's the reason for the title, Tactical Use of Propagation Predictions for HF Contests, and giving you a little bit of an edge and knowing what the propagation predictions show for a particular location that may be a location you've never even gone to before, for example, if you go on a de-expedition. Some propagation prediction tools that are out there in the In the market now are VOA cap, which stands for the Voice of America Computer-Aided Propagation, or predictions rather, a sub-species of VOA cap in the VOA cap suite of software called VOA Area. There's a new one, OH6BG. Yari has got this wonderful site on the internet, which you can find by Googling OH6BG VOA cap. And he not only has gotten a lot of written instructions on how to use a very complicated program like VOA cap or VOA Area, but he also is doing some customized propagation predictions as well. I recommend his site very highly. Then finally, I'll talk about what I'm here for. That is the N6BV prediction tables in order to do some propagation prediction. Okay, just a short, I'll go through the first part here rather quickly. The VOA cap, which is, as I said, the latest versions have been written by the Voice of America, the VOA. It's considered the gold standard of HF computer propagation programs, but it is, most people will recognize the fact that it is rather difficult to use. It's very, very comprehensive. It is a program that's been developed over about the last 30, maybe even 35 years now by agencies of the U.S. government. But it was written in Fortran and then translated first to microcomputer DOS and then to microcomputer Windows versions. It is difficult to use, to put it mildly. Or some people have called it user unfriendly or even user hostile. Now, VOA cap is for point-to-point predictions. That is, there's one transmitter site and the predictions are made to one receiver site. VOA cap produces lengthy tabular printouts that require a lot of interpretation and massaging. What they do is I refer to something that produces a lot of data as opposed to something that produces information that the human being can instantly recognize and use. Here, for example, is typical VOA cap output table. This is so-called method 25, which is called in VOA cap parlance all modes table. It is for a single frequency, in this case 14.1 megahertz. And the output file is rather large. It's about a quarter of a gigabyte of data, 250 kilobytes of data. And if you were to print it out, you would get about 28 printed pages on the old familiar tractor feed green and white paper that a line printer used to use on old mainframes. Some of you perhaps are old enough to recognize that old line printer terminology. Just for example here, this happens to be a computation for 14.1 megahertz. I've got my cursor here showing the 14.1 for a universal coordinated time of 15 Zulu hours, and it shows 6 different modes: 3F2, 4F2, 4E, 5F2, another 5F2, that's the so-called Pedersen wave, and a 5E hops. It shows the various angles, the launch angles going as low as 1.72 degrees. You notice how it's accurate out to 2 decimal points, whereas the ionosphere is accurate out to perhaps 1 at the very most. It shows a wealth of information, and it shows what I'm primarily interested in is the signal power, which is calibrated in terms of dB reference to 1 watt of output power. And then there's this printout of SNR, which means signal-to-noise ratio. This is done in a 1 hertz bandwidth, which I will talk about a bit later as being something that hams have some difficulty really assimilating and understanding totally. There's mode propagation, probabilities also. All right, that is VOA cap. VOA cap is also capable of producing these rather spectacular-looking color graphs. But what I maintain here, and I've said before in other seminars, that these colorful graphs are not really useful for contest planning, and that's the topic we're going to address tonight. Here, for example, is a VOA cap graph It's showing that that where the cursor is. In this particular case, the cursor is not shown, and I didn't capture the cursor. But at 14.04, 14.07 time, universal time, UTC of 14, that at 21.177 megahertz, the signal in reference to a dB, reference to 1 watt is minus 93 dB, dBW is what it's called. So this is very spectacular, and it looks certainly pretty and very impressive to print these out and put them up on the wall, but they don't give you a tremendous amount of big picture information for contest planning. Now, VOA area, which as I said is a subspecies of VOA cap, uses the VOA cap software computing engine to produce wide area, or area-wide rather, coverage from a single transmitting site for a single frequency. Here's an example of a VOA area graph that shows, in this case, SDBW, the signal strength again in dB below 1 watt, at this case 3.8 megahertz, 75 meter band in November at a very low level of solar activity, a smooth sunspot number of 10. The transmitter power in this case is 1.5 kilowatts. This dipole at 7 had its title truncated just a little bit. That's 75 feet. The transmitting site is San Francisco. The coverage is all across the United States of America, and the color calibration is S9 plus 20 dB is this red, very dark red. This dark brown color is S9 plus 10 dB. S9 is the orange, yellow is S7, and green is S5. Anything less than green, S3 is a blue, which isn't shown on this particular graph, and a nil signal, very low signal in the noise, would be gray. Well, this is certainly, it gives you at a single glance a great deal of information. It tells that, for example, on 75 meters from California, at best you're putting in for a rather large transmitter and antenna system, you're putting in an S7 signal into the east coast of the U.S. So transplant the site over to, let's say, Washington, D.C., and you've got a very similar coverage shown. In other words, you've got about an S9 plus 20 dB coverage showing most of the active places where there are hams in the United States on the East Coast and in the Middle West portion of the U.S. Okay, arguably VOA area charts are the most intuitive presentation of propagation data, as I've shown you, but they only cover a single frequency and a single UTC time. Now, this again makes it difficult to get really the big picture idea of what's happening out there propagation-wise, and it gives you less information than you really need to produce a plan for how to attack a particular contest. Now, it's possible to make several charts on several frequencies and combine them into a montage that is good for a single hour at a single time, and a series of these montages makes a sort of movie to use while operating. And I've shown this kind of movie of VOA area charts. I'll show it here quickly. This is starting in San Francisco again, and this would be for the November sweepstakes contest, which is a domestic contest where the U.S. and Canada work each other. The contest starts at 21 UTC, which at that time of the year in November is 13 UTC, 13 domestic time, in other words 1 p.m. in the afternoon. And what I've chosen to show here is what's happening on 20 meters, on 40 meters, and on 15 meters. And let's just take a quick, I'll step through this. This is at 15 meters at the start of the contest, where there's a strong signal being put out from this W6 into the areas of the Midwest, the Midwestern portion of the U.S. You'll notice also, by the way, how big a skip zone there is. Because the angles are relatively low, And there is a skip zone where there's no signal at all from an HF radio at 21 megahertz. You notice there's a smaller skip zone on 20 meters on 14.2 megahertz, and on 40 meters, at least at the start of the contest, which is 1 p.m. local time, there's very little of a skip zone showing. Keep your eyes focused on 15 meters here. This is at 22 UTC, 23 UTC. Now the band's beginning to fade. At 0 UTC, the band has gone to nothing. Now let's look at 20 meters here. Again, looking at the skip zone first. The primary area of coverage is in Colorado and Idaho and the western portion of the U.S., and it covers with a strong signal all the way out to the East Coast, S9 on the East Coast, and in the Midwest, S9 plus 10. Keep your eye on 20 meters here. This is 22 UTC, 23 UTC. Things are beginning to break up a little bit, and at 0, 0, 0 UTC, 4 hours into the contest, you can see that 20 meters is beginning to peter out pretty badly on the East Coast. Excuse me. By contrast, take a look at 40 meters. And at the beginning of the contest, there's a strong signal being put down into Colorado, but relatively weak signals S5 out on the East Coast. And 1 hour into the contest, 40 meters is stronger. Now we're putting on an S9 signal level into the Midwest, even stronger at 23 UTC, and at 0, 0 UTC, it's even stronger. So in a montage like this, into a movie like this, that is, of montages, there are a total of 24 different pages, and as I would operate the November sweepstakes at N6RO, where I normally operate, I would every hour would advance the computer screen so I could see what band would be most optimal. Okay, now VOA area, as intuitive as the movies are and showing tremendously useful information, don't really show what the competition is doing. In other words, how strong is the East Coast into Europe compared to a W6, for example? Well, the answer is much stronger. We poor suffering W6s trying to work Europe compared to the East Coast usually take a second place behind any East Coast station. Now, VOA movies, again, as spectacular as they look, cannot show you to predict on a particular band at a particular time whether it would be possible to run rate, okay, despite the competition into the rest of the world. Okay, now the latest N6BV prediction tables. Early tables were in the ARRL antenna book on the CD-ROM in the 20th and 21st editions of the ARRL antenna book, for which I was the editor, as Dean N6DE pointed out. The newest versions cover 240 transmitting QTHs around the world. They're actually, I think it's up to 244 at this point. The software, the prediction tables in the 21st edition of the antenna books had 170 QTHs, and the one in the 20th edition had, I think it was 150 transmitting QTHs. This is a graphical display using using pins to indicate what the coverage is for these 240 different transmitting QTHs. The U.S. is the ones in red. North America, including VE and XE, and the Central American, portions of North America are in dark blue. The ones in Oceania also in dark blue. The light blue covers the continent of South America. Green is Africa. Europe is light blue. Purple is Asia. So it's covering pretty much the total global around the world QTHs. Now, there are two sets of tables in the N6BV prediction tables, and that the first one is called the summary table, and the second one is called the detail table. Now, this shows a picture of the the summary table for, in this case, the month of October from San Francisco, California, for a low level of solar activity. This is smooth sunspot number. And the signals shown here are displayed are calibrated in S units. And there are 5 contest bands, 80, 40, 20, 15, and 10 meters. And the hours starting out at 0 UTC going to 23 UTC are shown here on in the vertical column, but they refer to each of the rows here. And that the 7 general areas in the world, EU is Europe, FE is Far East, SA is South America, AF is Africa, Asia is AS, OC is Oceania, and NA is North America. So this in one fell swoop, in one complete picture, gives you an overview on what the predicted conditions are for, in this case, October, for a low level of solar activity starting in a transmitting location in San Francisco. I went over the 7 general areas covered. I pointed out that the S units are those in are those calibrated in S units, and that the long path signals rather are shown as asterisks. Let's see if I can find. Yeah, over here, for example, it says that into the continent of Africa at 15 UTC on 20 meters, the long path will predominate at the start of the opening, and then it will go to short path later on in the day, and then end itself up as long path with the asterisk showing. Okay, the summary tables this is what are most useful for doing planning for a single operator all-band operation, something like a contest. It'll also give you a good big picture view on what the propagation is like if you go on a de-expedition to some exotic island that you've never been to before. It'll give you an idea on when the various portions of the world are favored by propagation. Okay, there are 6 levels in choosing the particular table, the prediction table. There are 6 levels of the 12 months smooth sunspot number, which is also referred to as smooth solar flux. Very low, which is smooth sunspot number 0 to 20, low 21 to 40. This were, in theory, in cycle 24, somewhere in this region, very low in this region. I should point out that the smooth sunspot number is a 12-month moving average, and so consequently, at any particular month, you do not know what the smooth is because you've got to go out 6 months in data ahead of this before you can back into looking at the actual SSN because of it's being a 12-month smoothed average. Now, there is something called the equivalent smooth sunspot number, which is produced by a company called NWRA down here. This is the URL for it. And what they do basically is they observe what the propagation is like and back into what the smooth sunspot number must be. You will find that there are times when the equivalent sunspot number is actually negative in this calculation, and that has been true, unfortunately, for about close to the last 4 years in the end of cycle 23 and the very slow start of cycle 24. Okay, now detailed. There are 2 summary tables. There are 2 different types of tables: the summary and the detailed. Let's look at the detailed one. Here is an example of, again, from October from California, San Francisco, for a low level of solar activity, and this is on 20 meters. There are 160, 80, 40, 30, 20, 17, 12, and 10 meters. Each one has a separate page in the detailed propagation prediction tables. Now, instead of, let's see if I can get my cursor back here. Hello, cursor. There you are. Instead of having the time as on the summary table going on the vertical axis, this is going on the horizontal axis, starting at 00 UTC and going out to 23 UTC. Now, and the vertical axis is now calibrated in terms of the CQ zones. Zone 1 is represented by KL7. Anchorage, Alaska is actually the terminus point there for the calculation. VO2 is Zone 2. Zone 3, Zone 4, Zone 5 are the primary coverage in the US of A. Zone 3 is W6 in San Francisco. W9 is Zone 4 in Chicago, and Zone 5 is W3 in Washington, D.C. Now, these tables have highlighted 3 different areas in the dark highlighting. The USA, Zone 3, 4, and 5. Europe, Zone 14, 15, and 16. And Japan, Zone 25. Now, what you're seeing here is a tremendous amount of data, and I'll be explaining for the rest of this webinar how to look at this data, how to massage this data. So this gives a complete snapshot of what the propagation predictions are for 40 worldwide CQ zones for the entire 24-hour period for October, with a smooth sunspot number that is low. Okay. Now, some of you have used VOA cap or even its earlier program called Ion cap. Anyway, the VOA cap developers recommend the use of SNR, signal-to-noise ratio. But yet, in the tables that I develop, I show signal strength in S units. Now, why is that? Well, the first reason, excuse me, I take a drink of water. The first reason is that hams understand S units. They're not particularly comfortable with SNR measurements in 1 hertz bandwidth. Now, especially on the lower frequency bands, the signal-to-noise ratio is determined largely by what I call power line types of noise. Now, that's not only the arcing insulators on a utility pole outside your house, but it can also be someone's computer switching power supply, which they have conveniently removed a number of the filter components to make the power supply cheaper, but which these switching power supplies put garbage back onto the line and eventually is radiated by power lines outside the house. So especially on the lower bands, the signal-to-noise ratio, the SNR, is determined largely by power line types of noise and by thunderstorm activity. Now, assuming that your local power company, in our case out here in Northern California, it's Pacific Gas and Electric, PG&E, assuming that they've cooperated a lot and that they've cleared the noisy insulators and tightened the ground hardware and such, there are those wonderful, I emphasize the word wonderful, rare nights when there is no thunderstorm nearby and an S5 signal on 80 meters sounds like it is an S9. It's just absolutely wonderful to behold times like that. They're not that common. Now, if the propagation predictions for a particular circuit show S5 on 80 meters without the noise from thunderstorms, it sounds as though it's S9. What happens if the thunderstorm Q or Nancy itself, the thunderstorm static crashes, is S9? Well, you know you're not going to be able to hear an S5 signal in there. Okay. As I alluded to, the new detailed prediction tables include the so-called work bands. Well, if you're an old-timer, back in 1979, there was a World Administrative Radio Conference, a work meeting, and they allocated 30, 17, and 12 meters to the traditional 160, 80, 40, 20, 15, and 10-meter amateur bands. I have been asked by a number of people to include 30, 17, and 12 meters, so I do in the latest tables. Okay, now here's an example of a new 30-meter table, again for the month of October for a low level of solar activity. What's interesting to note is that the 20-meter band is open to Europe 24 hours a day. The 30-meter band, the 10 megahertz, a 30-meter band is open to Europe at some relatively low levels in the middle of the day, but still it's open 24 hours a day into Europe from San Francisco. It's a marvelous band. All right, now some details about the prediction tables. The antennas used in VOA cap to predict signals levels are isotropics with gain, which sounds like a misnomer at best. Isotropic has a circular pattern in azimuth and a circular pattern in elevation, and it is a theoretical kind of antenna. But they do cover all the angles, and what they emulate as antennas used in the older tables were a 100-foot dipole for 80 and 40 meters, a 3-element 20-meter Yagi at 100 feet, just about 30 meters in height, and at 10 meters and 15 meters, the antennas used in the older tables were 4-element 15 and a 4-element 10 at 60 feet in height, almost 20 meters high. Now, the isotropic antennas with gain cover all the way down to 1 degree. I chop them off below 1 degree, which simulates pretty much a mountaintop location. And some people have in fact called my choice of antennas a mountaintop superstation. Now, in the new tables, the long path algorithm has been improved compared to the older tables, and that allows many weak signal long path signals to show. Many weak asterisk marked entries in the table show long path. Now, this is important that the gain antennas, these so-called isotropics with gain, are assumed to be optimally oriented to and from each QTH. That's another reason why I chose isotropic antennas with VOA cap, because they allow the antennas to be automatically rotated since they have equal radiation in all directions of azimuth. They line up for optimal propagation from one QTH to another. This will be very important to recognize as we look into some more details on the prediction charts for interference, let's say in Europe, from European stations to European stations. All right, so some people have questioned, gee, why did you choose superstations on mountaintops, and why did you choose 1500 watts? After all, I run 100 watts, and I've got my dipole up 30 feet in the air. Why don't you make propagation predictions for me? Well, if I tailored the prediction specifically for a little gun station with 100 watts and a 30-foot high dipole, many of the weaker signals shown in the tables they'd just simply disappear. And with nothing showing, you wouldn't have any inkling at all. You wouldn't have any idea that propagation is even possible. So I prefer to show the big gun stations, and that is a station on a big gun station on a mountaintop. And if you really want to see how much weaker a little gun station is compared to this mountaintop superstation, what you would do as rules of thumb is subtract 2 S units if you had a 100-foot high dipole instead of a 20-meter 3-element Yagi at 100 feet. That's the compensation factor, 2 S units. You'd have 3 S units for a dipole at 50 feet instead of a 3-element Yagi at 100 feet. You'd subtract, again, 3 S units for a dipole at 30 feet instead of a 4-element 15 or 4-element 10 at 60 feet. Again, these are just rules of thumb. And incidentally, I should point out that my S unit emulates the activity of a rather typical receiver, which has between 4 and 5 dB per S unit. It doesn't come up to the ideal 6 dB per S unit that Collins Radio pioneered the definitions maybe 50 years ago. Real receivers are between 4 and 5 dB per S unit. Now, if you have a dipole at 50 feet on the lower frequency bands, 160 to 30 meters, rather than a dipole at 100 feet, you subtract 1 S unit. For power, if you've got 100 watts instead of 1500 watts, which the prediction tables use, subtract 3 S units. And if you're running QRP at 5 watts rather than 1500 watts, you subtract 6 S units. So, and this is an important aspect also, the large antennas, the mountaintop antennas for a superstation are assumed at both ends of the circuit, both the receiving and the transmitting ends of the circuit. Okay, let's just take a quick example, again, using California, San Francisco, California. Let's take a look at zone 15, which is in southern Europe, at 15 hours Zulu time, UTC time. Now, the signals for that big gun station, the guy on the mountaintop with a superstation, is S7. If you assume a 20-meter station which has a dipole at 50 feet, and instead of using 1,500 watts of power, uses 100 watts of power, and again, this assumes that the receiving station is a 3-element 20-meter Yagi at 100 feet. S7 starting off with -3 S units for a dipole at 50 feet, -3 S units for a 100-watt signal produces a grand total of S1. So from starting at S1 for a mountaintop station, you're down to S1 for a little gun, 3-element Yagi, a dipole at 30 feet. So it's unlikely to make you stand out in a pileup very much, except for being weak. And again, the same thing holds. Let's say you put a superstation 3-element Yagi at 100 feet, but you only use QRP. Well, the same thing. S7 minus 6 equals S1. And the obvious thing is that QRP is challenging even with big antennas, but you knew that already. I saw this little sign, do not pass when opposing traffic is present. And I thought about it. Do not pass when opposing traffic is present. And you know, the kids nowadays would say, well, duh, of course it is. But wait a moment, there is a contest equivalent. And it is, the frequency is in use. Thank you for asking. In other words, stay out of my lane translates to stay off my frequency. We don't want to crash on the frequency. That's my frequency. But I digress. All right, cycle 24. Let's take a look at planning. Cycle 24 is finally beginning to ramp up, although it's fitfully. Some days there's no sunspots whatsoever. Some days there are a few, but they seem to be going up. And now that we are blessed with more band choices of open bands, how does a single operator, all band, know where to be, what frequency to be, and when to be there? And I maintain that first you need to assess your own station. You want to know whether your station is strong enough to run rate, that is to call CQ and hold the frequency, or whether you must search in pounds, S and P, in order to work any stations. This is after a lot of discussion with a lot of people and operating DX contests in various parts of the world myself. I'm convinced that effective running, that is CQing into Europe, takes a signal strength of at least S8 from the USA, and it even takes S9. Why is this so? Why S8? Because, very frankly, European pileups quickly degenerate into chaos. Whoops, what happened here? I seem to have gotten something up on my screen. Okay, let's see if that works. Okay, sorry about that. So European pileups quickly degenerate into chaos because they can't easily hear the CQing station over all the other Europeans who are calling and calling and calling. To put it mildly, JAs are usually much more polite, and even U.S. stations, as impolite as they can be at times, are generally more polite than the European pileups that just keep calling and calling. Let's see if I got control. Okay. Now, here's another personal peeve. Packet pileups on CW, they can really slow down the rate. I can tell whenever I'm operating at N6RO and get spotted on CW by packet, because everyone comes on instantly swoops to the frequency, and they're on exactly the same frequency, except for the few smart guys who know that they should tune off a couple of 100 hertz and then give me a call. So this is a hint, guys. Don't just take a packet spot and hit the Alt F3 key or whatever your software uses, and go shooting off at exactly the same frequency. It's impossible to pull a call sign out of the pilot when they're all on the same frequency. All right, I'm going to use a single operator all bands, single operator 2 radio, SO2R, and I'm going to use the WPXCW contest as an example. This is an example on how to do your contest strategy. And I'm going to do it from California to the rest of the world. I apologize to the guys in Europe. This is a U.S. kind of centric talk, but you can do after this. After you go through this webinar, you should be able to do it for your own location as well. All right. There are some particular or peculiar rules for CQ WPX contests, and that is that anyone can be a multiplier in WPX. In other words, the first WB6 that you work is just as valuable as a multiplier as the first JT1 you work. So one of the things you've got to avoid is becoming a DXer and just chasing new multipliers, because what happens is, that's most important in the WPX, is running rate. In other words, if you can CQ effectively, if you can get answers back to your CQs, the multipliers will come to you in WPX. Now, in contacts from between USA to USA, they used to be worth 0 points, but they might count as a multiplier if there's a new prefix. Nowadays, within the last couple of years, the rules have been changed such that USA to USA contacts, that is one country to the same country, count as 1 point. QSOs to other continents are worth more. For example, on 20, 15, and 10 meters, intercontinental QSOs are worth 3 points. And the obvious implication is that W6s should run Europe or JA or Japan if they possibly can. Now on the lower bands, 160, 80, and 40 meters, continent to continent, intercontinental QSOs are worth 6 points. And that's versus 3 points in the higher bands. So it behooves you to try to work as much stuff as you can on the lower frequency bands, because they're worth more. Now, I should point out that JAs do not have a frequency allocation for use in Japan on sideband, but they do have it on CW, so you'll find JAs on 160. And even though Ws are only worth a single point, they, as opposed to 0 points, they could easily be new prefix multipliers. So that's valuable to work Ws, to work US stations, even though you're in the US, because they represent a lot of prefix multipliers. Now again, let me point out that S8 or even S9 allows you to run CQ and run rate. Now my modus operandi when I'm doing a plan is that I will spend as much of a couple of hours poring over the summary propagation prediction and backed up by the detailed propagation predictions for each band. And what I do is I use a yellow highlighter to flag interesting openings, especially openings where the predicted signal strength is S8 or more, because you can run CQ at that point. You can run station. What I would do is I'd start in the highest frequency band, in this case 10 meters, right over here, 10 meters, and I'd highlight in yellow interesting openings, interesting predictions. Notice this one. It says that North America at 02 Zulu on 10 meters, even at a low level of solar activity in May, which is the WPX contest, there's a signal here in North America, S8. Well, let's take a look at the details. The details said at 02 in zone 6, which is part of North America, the predicted signal level is S8. Well, unfortunately, there's not that many XE stations on the air. There might be a half dozen or maybe a dozen or so that you'd work in a contest. But it's not saying that you're going to be able to work Ws. In this case, W4s or W5s are showing as very, very weak. Even at the 22 and 23 hours is predicted to be an S1 long path. These S6 or S7s are local W6s. If I'm in San Francisco, I'll be able to work some locals there. Okay, now we'll do the same sort of thing. We've highlighted the interesting openings including an opening into Asia on 10 meters. Now we'll do the similar sort of thing, hand mark up the printout for 15 meters. And looking at the details for 15 meters, you can see that starting at the 00 Zulu until 03 Zulu, there's some part of the U.S. that's open with an S8 or S9 level signal, S9 plus at the start of a contest. And throughout the whole day, after sunrise in California, there's S8 to S9 level signals predicted for W5. So the best bet if you're to run rate on 15 meters would be having your antenna pointed towards W3 and work a bunch of one-pointers and get as many multipliers as you can. However, you should be aware that there is short, weak, long path openings on even at a low level of solar activity, because it's in May, where it's almost summertime. There are predictions for relatively weak, but still there, long path openings starting at 16 Zulu, or just about. It should last for about 3 hours. And in fact, there's opening at during the dark hours in San Francisco. For example, at 06, a long path opening into zone 14 and 15 is predicted, even though it's only S5. The trouble is there's relatively few Europeans who know that this is a possibility, so they don't turn their beam for long paths. All right. Next, you do 20 meters highlighting, again, S8 or S9. And, well, you can see that there's an awful lot of yellow on 20 meters. Something's open somewhere in the world on 20 meters, even at a low level of solar activity. You'll note that one of the things that it's a little peculiar to 20 meters, it happens more on 20 meters than the other bands, is that the band will often start strong, S8, let's say, into JA from California. It'll then drop to S6 in the next couple of hours, and then come back again at S8 to S9. Well, what's happening is that it's reflecting the fact that around local noontime in Japan, the 20-meter band gets weaker. But don't make the mistake of giving up on 20 meters just because the band fades for a while. It's probably going to be coming back again. Okay, again, the yellows show where it should be possible to run, to call CQ and run stations. Okay, this is what I refer to as horse races. It's useful to compare signals from all over the world into a receiver in a desired target location. There used to be a song, I don't know, 30 years ago about walk a mile in his shoes, walk a mile in somebody else's shoes, and this is the electronic equivalent of it, of walking that mile in his shoes. Is let's plop ourselves down at his receiver and see what he's hearing. And what I'll do is I'll do some examples using Southern Europe, that is Rome, and Eastern Europe in Moscow for the WPX-CW contest in May. This is, again, at a low level of solar activity, the level we're enjoying now. And what I'll be doing is using the detailed propagation predictions. Now, what is the horse race going on here? Remember, the three portions of the world that are highly populated from an amateur point of view are the USA, Europe, and Japan. And therefore, the competition for any particular station in W6, let's say, the competition is from the USA, from Europe, and from Japan. Now let's look at 20 meters. Again, this is at Italy in the month of May for a low level of solar activity, and flag things of interest. Let's compare, first of all, this S8 predicted at 06 Zulu, 06 UTC, compared to the rest of the USA. Even at 05, S6 is stronger than S4 or S1 predicted in W9 or W3. All of these signals predicted for W6 into Europe are stronger than in this green box here, and also in this green box and in this green box over here. All of these signals in W6 are predicted to be stronger than W3 or W9, W9, W3. But what's happening in Europe at this time? Let's at 06 Zulu. Well, there's predicted to be an S9 level signal coming out of England into Rome, and an S9 plus, at least 10 dB, coming out of UA3, coming out of Moscow into Rome. Compared to Japan, the signal level is S6, so the only guys we'd have to worry about is we don't have to worry about the W3s and the W9s or the JAs, but we do have to worry about what the Europeans are hearing in Europe. Okay, moving on. What happens is that the actual antenna patterns of both the transmitting and the receiving stations are important. This is an area coverage map showing the isotropic antennas used in predictions. Rome's signal strength in San Francisco, right around here, is about S7 or so, S7 or S8. It's difficult to see detail because this map shows a relatively large amount of geographic area. You'll notice that it distorts the look of the North American continent. It makes it difficult to understand where things are until you mark the cities. But let's take a look at this area right in here so we can get some more detail. This is the signal strength predicted into Rome, or from Rome, but since it's a reciprocal relationship, transmit and receive, it says that in Moscow, a Roman station transmitting with an omnidirectional antenna would put out an S9 plus 10 level interfering signal. Into London, it would put out somewhere between S7 and S9 level signal into London. What this is assuming effectively is that the receive antennas in every one of these locations is aimed at Rome. Now, this is a azimuth projection of, again, Italy. You'll note that the path towards W6, towards the west coast of the USA, is virtually exactly the same path as it is to get from Rome to Italy. Similarly, the path from Rome to Moscow is the same path as it is to JA. Here's a typical beam response of a 3-element Yagi, a small Yagi, a 16-foot boom, and it shows that in the direction, if the Roman station is pointing towards W6, he's pointing at 325 degrees, and that's the same azimuth for England. And he would be pointing at an azimuth of 40 degrees towards UA3 and JA. This is the area covered chart for these types of antennas. In this case, what I've assumed is a 3-element Yagi at 75 feet on 20 meters from Rome. I'm assuming that the European receiving antennas now are the same 3-element Yagis at 75 feet, but now instead of being aimed at Rome, these Yagis are pointed at W6, which creates a situation where a Moscow station is about S3, as is a London station, S3, as opposed to being S9 plus at least 10 dB in Moscow. In other words, the patterns of the 3-element Yagis have improved the situation on the European being able to hear a W6 in spite of QRM from Europe. Now, this is the situation for Eastern Europe, European Russia, for a station located in Moscow. The green box that I showed you before is showing where the W6 has an advantage over a W3 or a W9 occurs for a longer period of time. The path from the west coast into Eastern Europe, into Moscow, is a little bit more advantageous than it is for a W6 than it is for a W3, some on 20 meters, which is kind of interesting. Again, the azimuths, they're different to England, from Moscow to Italy to Japan to W6. This is a typical 20 meter, a 5-element 20. Instead of a 3-element, I decided to show a 5-element, where where's my cursor again? Here we go. Where JA is in the notch, the front to rear notch, as well as G and another Italian station. Okay, now, by the way, the azimuthal response of a 5-element 5/5 vertical stack will be the same in Moscow. When you stack the verticals, horizontally polarized Yagis in a vertical stack, you change the elevation response, but you don't change the azimuth response. What does it look like when you do it in an area coverage chart? This is for 5/5/5 transmitting stack. That's what I happen to use at N6RO, so I thought I'd show it. From Moscow to the U.S., and this is assuming that the European receiving antennas are the same 5/5/5 stacks. This time they're aimed at W6 rather than being aimed at Rome. Being aimed at Moscow. Because they do change the elevation response, stacks will tend to suppress higher elevation angles. They're taking that energy in the higher angles and they're squeezing it down into the lower lobe. All right, so it turns out that on 20, 15, and 10 meters anyway, the interfering signals from within Europe, in other words, Europe interfering with Europe, aren't as frighteningly large as it first looks like. And this is providing, of course, that directional Yagis or directional antennas are used in Europe, and providing that they're all pointing towards the USA, not pointing at a particular target location in Europe itself. So stacks can extend the skip zone a little. And the guys that actually gave you the most trouble in Europe are using omnidirectional type of antennas like verticals, because they don't have the pattern that will put a null in the right direction for European to European QR Mexico, QRM. Below 20 meters, like on 40 and 80 and 160, highly directional antennas are less likely to be found. And there, the skip zones naturally decrease in size, so the ability to copy a W6 under the huge signals on 40 meters becomes a lot more challenging, because highly directional antennas are not available at most stations. Okay, here's the final result. Now I've put the yellow markers on 40 meters and 80 meters. This is the complete picture. This is the data that you use to produce a planning chart. This gives you some of the details on 40 meters from San Francisco to the 40 zones, or 40 CQ zones all around the world. And what about time off? Well, one of the rules in WPX is that you can only, as a single operator, you can only operate 36 out of 48 hours that the contest is on. So you'll have to plan it. Take a look at when you expect the predicted rates are lowest, or simply when you're sleepy. In other words, things might be different on the second night compared to the first night of a contest. Now, the plan to do a band plan, you pick a band in which you expect to run rate, and you have to recognize that there may be 2 or sometimes even 3 bands where you can run rate. You have to choose the one that's open to other continents, rather than, in the case of the U.S., trying to work only U.S. to U.S. stations, because the intercontinental QSOs are worth more points. And of course, they're worth more points on the lower frequencies than they are on the higher frequencies. And the strategy would be to use a second radio to find multipliers, and even just regular QSOs on other bands. Okay, here's again, I repeat that summary sheet that I showed just a few slides ago, just so I can flip back and forth. This is the final product. This is what takes an hour, maybe even 2 hours to make a band plan. And what it is showing is that the yellow over here indicates a condition where the signal strength is at least S8 or perhaps even S9, and you should try calling CQ yourself. So let's just take a quick look at the start of the contest. I would start on 20 meters running JAs and Ws. Well, I don't have a chart showing the azimuthal directions, but towards the U.S. It's a beam heading of about 70 degrees. Towards Japan, it's a beam heading of about 305 degrees, which means that they're almost orthogonal to each other. And so in order to run JA and W simultaneously, I have various beams in a vertical stack pointing in different directions. So normally, most West Coasters think, well, the first thing you're going to do when you open up on an HF contest is you want to run 15, the highest band that's open, running JAs, but it's more profitable to run JAs at the on 20 meters rather than it is on 15 meters, simply because you can also pick up JAs on 15 as you do searching and pouncing. Well, the only time you have to make a choice on whether to run on 40, which is the only predicted time where Europeans are strong enough to run on 40 meters, is at 05 Zulu. So I would, you got your choice, run either on 20 meters, running JAs, Europeans, and Ws, or run Europeans and Ws on 40 meters. Similarly, it outlines where you, for example, here on 12 Zulu, just before daylight in California, you can run Ws, but if you can run Ws and JAs at 12 Zulu on 40 meters, they're worth more points. Okay, getting to the end of this, you guys, and just about an hour into it. Planning is important because it alerts you to possible openings you may never have experienced, and it shows what your competition is doing, or why you can run a pileup because your competition is weaker. But I want to point out that propagation is, this is all statistical, guys. The propagation is always changing, and you've got to develop a second sense of how things are actually going during a contest. Be aware of what is actually happening on the bands. That's what separates the also-rans from the winners. And this is a blatant ad. Where can you get the latest N6BV propagation predictions? The exclusive distributor for them is RadioWare. That's Craig Clark, K1QX, and it's also known as Radio Bookstore. You can do a search using Google on Radio Bookstore or RadioWare, and you'll find that this is the URL. Okay, that's the end of it, Ken.
Okay, very good. Excellent, Dean. We've got a couple of questions that have come in already, but let me just recap. You have two options. Basically, if you have a question, one is the text box where you just type in your question and hit send, and make sure you hit send or we'll never see it. Or if you've got a microphone connected and you'd like to speak to us directly, what you can do on your little grab tab, that rectangular box, the small one, is you've got a hand icon and you click on that, and it's similar to sitting in a classroom and raising your hand. What'll happen is I'll pick you up, I will unmute your microphone, and you can go ahead and speak to us directly. Otherwise everyone's microphone remains muted. So let me go ahead and pull up the first couple questions for you here, Dean. The first one comes from Rich W6 Alpha Papa Zulu, and if you want to go back to slide 59 while I read this,
okay, let's see.
References that slide. And the question is, does the subtracted S units shown apply to both ends of the circuit? In other words, does one have to subtract twice the number of S units for both ends of the circuit?
The answer is yes. You'd have to subtract in that case where I demonstrated a three-element or a total S unit drop of 6 S units because of the antennas and the power, bringing it down to S1. If the other guy on the other side, on the receiving side, had a small antenna, let's say a dipole at 50 feet, he'd have to subtract an additional 3. So that would bring it down to S minus 2, obviously an impossible situation.
Okay, good. Bud asks, how would you compare W6EL prop to the results in VOA cap?
Well, W6EL prop uses a simplified propagation algorithm developed by a gentleman named Fricker in the UK. It's simplified. It gives reasonable results, but VOA cap is considered the gold standard.
Okay, and along that line, I see another question here from Barry Kasich Sugar Tango asking about the difference between VOA cap and ACE HF propagation software.
Okay, hi Barry. Yeah, the ACE propagation software uses the VOA cap engine. It just packages it in a much prettier package and provides some unique graphs as well. But it's just because it's using the VOA cap engine, it's just as accurate.
Okay, Sal, K2 Queen Mike Fox, slide number 86. And I think you probably answered this at the end here anyways, but how do we get these charts for our location?
Well, RadioWare has got them.
I think the question was
By the
probably
way,
sent in before.
the price, by the way, is $30.
Okay. All right, come on, guys. Let's get some more questions in here. You got the expert on this stuff, and I was kind of joking with Dean before we got started that for an encore we were going to see if we could get him to produce some sunspots, but I think that's probably out of his capabilities. Okay, well, let's see here. Any last questions? Go ahead and fire them in now, or I'm sure Dean would take questions after the webinar as well. Was it N6BV at arrl.net for your email?
That's correct, arrl.net. Yeah.
Okay. All right, Barry asks, is there a real-time propagation versus actually what is happening on the air? And I guess is there some way to, you do your charts ahead of time, but as the contest goes on, is there some way to update them or get a little bit more real-time information?
Well, the only real-time aspect of it is assessing what the smooth sunspot number is actually. I mean, you're fixed on a particular month and starting out with a particular transmitting location, and you can bump up. Very often, what I'll do, like at this time of the solar cycle 24, it's somewhere between very low and low. So I will print up both sets of prediction tables. By the way, what these tables are linked PDFs. Again, 240 plus QTHs around the world. Each one brings up. Well, in fact, Ken, am I still showing on the screen?
Yes, you are. Uh-huh.
Let me just show exactly how this is used. I'm bringing up N6BV propagation PDFs, and it will bring up Adobe Acrobat. Okay, now what you can do is, if you're interested, let's say, in a detailed table for, I don't know, Georgetown, Guyana, just to pick one, you're presented with a choice of very low, low, medium, high, very high, and ultra high solar activity. So let's take, just for the heck of it, the month of February, the ARRL DX contest for a high level of solar activity. So what you will see is, in this case, it'll do the first 160 meters, 160 meters, 80 meters, 40 meters, 30 meters, 20 meters, 17, 15, 12, 10. Now, by the way, it is mentioned in the instructions, if you want to print this thing out, you can, but you're going to get about 600 or 600 or 700 pages of printout for each location. So what you would do is you'd figure out from 10 meters, let's say you want to print 10 and 15 meters, well, you'd print page 235 and 234 so you don't print out the entire PDF. Does that answer the question, Barry?
Okay, we'll see. You can ask again if not. Okay, but W2RU, have you considered converting your manually generated highlighting and comparing techniques to software? Actually putting it in a software package.
Well, yeah, hi, Bud. A long time. We've talked to, I guess that's K2KIR originally, wasn't it? It could be done, yes. As it stands, these things took about 3 days of computing solid to produce the 244 QSO, 244 transmitting QTHs. Yeah, it could be done. I'm getting too old for this sort of stuff. I don't think I'm going to do it. Someone may.
And by the way, he did confirm you had that call right, the K2 call. So, okay, another software comparison: VOA cap versus ICE cap, and I guess it's probably the same. But any comments on that?
Well, the IceCap version is a specialized version that was calibrated for transpolar, primarily signals transiting the North Pole. It's not validated by the VOA people anyway. So they recommend caution on using it, and a number of people have said that it is a little bit more accurate on some paths, but falls far below what VOA cap can do on most paths. So in general, I stay away from ice cap.
Okay, K6VVA, is there a rule of thumb factor we can use to mentally adjust the table data based on, again, updated A and K indexes, as the contest is going on?
These propagation prediction, hi Rick, first of all, brother Rick. These propagation predictions are done for quiet geomagnetic conditions. Unfortunately, in the latest version of CQWPX contest, the CW version just a couple weeks ago, we were hit with pretty high solar activity, not sunspot activity, but an EME. What's the name of it? A coronal mass explosion.
CME.
Yeah, CME.
That's it, CME, that's it. My mind went totally blank there. We were hit by that, and we had A's that got into the high 20s, and that disturbed greatly the transpolar paths. And in California, anyway, it made the Europeans very, very, very difficult to work at all. And on the East Coast, my understanding was that the Europeans weren't all that good either, but their transpolar path to JA, a number of the big gun stations said they didn't work any JA at all. So the answer to your question is no. These predictions do not include A and K index, but you'll know that if the A goes up, even though the predictions say that they'll be there, they may be there, but they would be awfully weak.
Okay, Dale asks, have you compared W7 to W6 Cheyenne instead of San Francisco? And let's see here. It's on a different aspect. We all know props change. So in reference, I guess this is to your sign. Don't run into the road sign. Okay, I'm not sure. I'm missing something there. Again, comparing W6 to W7. Any comments?
Okay, I'm bringing up on my screen. Let's see. Let's show you W7. There's separate predictions made for Phoenix, Boise, Helena, Montana, Las Vegas, Portland, Oregon, Salt Lake City, Seattle, Washington, and Cheyenne, Wyoming. That should probably cover the territory that you're interested in, I think.
Okay. I know you mentioned this, maybe just a clarification. This one comes from Jim, WAWTS, regarding the 12 dBi isotropic antenna definition. Does that imply an isotropic radiator with effectively 12 dB of additional feed point transmit power, or is it on the receive side?
Well, on the receive side, it's both receive and transmit antennas can be calibrated for more gain. As I said, it's something of a misnomer to talk about an isotropic antenna with gain, but VOA allows you to adjust on the transmitter side the gain of an isotropic. In this case, I set it to 12 dBi over ground for 20 meters, and let's see, I kind of lost track of what the rest of the question was there. Help me, guys.
And I deleted it.
Oh, that's good. I deleted it mentally, and you deleted it electronically.
See if I can.
No, the question was dBi and 12 dBi.
Oh, that's right. Yeah.
Yeah, you've got the option of changing the power level in VOA cap and the transmit gain for an isotropic. So there are a lot of variables you can play with, but what I kept constant was 1,500 watts in isotropic with a certain amount of gain depending on the frequency band. And use the same antenna at both the receive and transmit sides of the path.
Okay, got a couple more here. Frank says the next contest is fielding. Any suggestions for East Coast stations? 40 and 80 meters maybe? I mean, with the current conditions, I'm basing
with the current conditions, you're going to be doing everything on 20, 40, and 80, and probably a lot more on 80 than you'd expect.
And pray for no thunderstorms.
Well, that depends. If you're a W6, you pray for thunderstorms in W3.
Yeah, that's right. Well, field day isn't sweepstakes, so. Okay, Richard, NU6T, for a barefoot and wire station for contest planning, would you assume that you are working super stations or at least top stations on the other end?
Yeah, just again to show show the numbers, show any numbers, and when the propagation is poor, I assume a mountaintop superstation on the receive end just as well as the transmit side. And hi, Rich.
Okay, let's see here. Peter W2CDO, is there a correlation between solar flux levels and openings? Can we match SFI levels to the categories of SSN for purposes of determining S levels?
Yeah, you can use smooth solar flux as well. There's in chapter, I think it's 23 in the antenna book under propagation, you can see the mathematical formulas to translate between solar flux and sunspot numbers. So again, in the instructions for the use of the prediction tables, there is instructions on what levels to see. As I said, it uses very low, low, medium, high, very high, and ultra high as the smooth sunspot numbers, as the general indication, in other words, of what the propagation conditions are.
Okay, and we've kind of touched on this last question, but as far as real-time online propagation websites to kind of monitor things during contests, to be honest with you, I'm not familiar with what's available. Do you know any that maybe we could just mention?
Well, yeah, the Australian IPS, Italy Papa Sierra site gives real-time F sub 0, F sub 0, F sub 2 graphs or charts rather, but again, that's not terribly useful for us. It shows what could happen, for example, on NVIS, near vertical incidence skywave propagation, because the F sub 0, F sub O, excuse me, or the ordinary frequency of the F sub 2 layer is the frequency at which a vertically a signal beamed right straight up, a cloud warmer signal would reflect or not from that F2 layer. So it'll give you some indication, and you can use some rules of thumb for how oblique angle radiation changes compared to directly overhead radiation.
Okay, last question, and this one comes from Frank again. From your previous webinar, I've used HFTA to understand my location. How do I use those results with your prediction tables? Just assume a pseudo height for the antenna?
Yeah, that's what I would do. I'm working on, eventually I'm going to change HFTA to actually include the terrain profile, instead of so that you can use it as an antenna file for VOA cap or VOA area. But if you know that from your HFTA analysis over real ground that you've got a certain amount of gain at let's say 10 to 20 degrees of elevation, or 5 to 20 degrees of elevation angle on, let's say, 20 meters, if you know that compared to a straight dipole over or the same Miyagi over flat ground, that you've got an additional 10 dB, let's say, at 5 degrees, well, you've been very blessed with that amount of extra gain. So the antenna, the predictions and the propagation prediction tables would be augmented by, in that case, 10 dB.
Okay, why don't you just put up that last slide again where they can get the tables and stuff. We had one question, and give you a chance to go ahead and plug that one final time here.
Just Google RadioWare, or else http://www.radio-ware.com. and that'll take you to Craig's website.
Okay, very good. Well, I'm going to go ahead and grab the presentation roll back from you. I'll just do it from this end, Dean. And
okay, Ken.
Let me go ahead and put this up. Dean, N6DE, do you have any other comments you want to add before we close her down?
I just want to thank PVRC for hosting tonight's webinar, and to Dean N6BV for another great presentation. Yeah, and I would echo that as well, Dean. Excellent stuff, and really glad that you're joining us and sharing all the information with the group here. Really do appreciate it. I, at the moment, don't have a schedule for upcoming presentations. There are a couple that I'm working on. I think some excellent topics, but I haven't nailed that down yet. So what I would say is keep an eye on the PVRC webpage. The recorded event, which this one was recorded, that'll be posted on the PVRC webpage along with any upcoming webinars, and of course we'll send out announcements as well. Please pass the word to your friends and other club members. Let them know what we're doing, and get them to sign up and to join us. If you got any suggestions on topics, things you'd like to see contest related, by all means drop me an email. We'll see what we can do, and if you want to recommend someone for doing a presentation, that'd be great as well. We're always open to ideas and suggestions. So with that, Dean, N6BV, Dean, anything else before we close her down? Or?
No, thank you for listening attentively to me blather for more than an hour.
Not at all. Certainly our pleasure. All right, thanks everyone for attending, and we'll see you next time. 73, so long.
Thank you, Ken.
Mm-hmm.